This video will help you succeed laying Marklin K-tracks, cutting, soldering sub-panel turnout motors for high reliability and realistic operation.
Hello and welcome to a video tutorial in which we will deep dive into the assembly work around Marklin K-track. This video is sponsored by Traingamia. Traingamia is a public model railroad in Copenhagen, Denmark. It has all the features of a public layout, like an amazing scenery, fun animations which are started by a press of a button. But besides from that, Traingamia differs from all the others because the visitors control the trains. When arriving to Traingamia, you get a game card. Your progress level and experience is linked to that card. You swipe the card on the side of the operator console and you're ready to start your journey on Traingamia. Every new mission you run has unique features and challenges, starting with very basic throttle and brake control, and from that point adding in signal aspect, stopping points, speed limits, speed dynamics based on the weight of train, uphill incline or the downhill incline. And every new mission gives you experience points and lets you reach new levels and gain rank. Challenge yourself or your friends to see who's the best train driver on Traingamia. And we're gonna start working with Marklin K-track.
Let's start by looking at the tools needed to assemble K-track. These are the cutting tools, these are the joining tools, and up here to the right is soldering, which needs for joining and connecting electrics. This is a rail nipper. It's a side cutter with one side flat, commonly used to cut rails. I'm not a great fan of a rail nipper or rail cutter for this type of tracks, which is made of stainless steel. It's a bit too hard, so I prefer using this. This is a motor grinder with an extension. The extension is just screwed in place up front here, so it's a kind of accessory for this motor grinder. This motor grinder is a Dremel. It has some advantages. It has battery power, so you don't have to have cords lying around on the layout while laying your tracks. Otherwise, a low-cost motor grinder, they're just as good, but they're typically lacking at the accessories. So this is a great motor grinder. It's half of the cost, but when you try to cut the rails, it's not possible to cut them straight because the diameter of the motor grinder is greater than the blade. Here's my extension for the Dremel instead. Here I can make a perfect 90-degree cut in the rails, which is absolutely necessary when cutting rails. We also need some track screws. This is the Marklin track screw for K-track. It has a recessed Phillips head and it's blackened, so it's kind of stealthy where it sits in the ties or in the sleepers. These are rail joiners. This package is provided by my vendor, Train Shop here in Sweden, and contains just the rail joiners. I'm not a great fan of the spring contacts for the center rail, which is provided in this set from Marklin, which is called 7595. And this one, well, here you see the spring contact, which should be clicked in place. Easy to do when you have the track like this, but not when it's curved lying on the track bed. Here is the rail joiner now pushed in place, and here on the rear side you see the contacts for the third rail. So it has two contacts, one under each rail. Here's my soldering iron. It's a kind of soldering station. It's nothing special really. I have this sponge to clean the tip, which is a really good thing to have. It should be slightly wetted. I can also set the temperature for my solder, which is good. If you're soldering something of more mass, then you can increase the temperature. Then of course you need solder wire. This is flux cord solder wire, 1 millimeter diameter. It's a bit on the thick end. I prefer 0.7, but I'm out of this. And then you need this. This is an absolutely must when soldering on K-track. This is a flux, which is specially for soldering to steel and stainless steel. And as you see here, it's a clear liquid, which makes magic when soldering to steel. So we're going to compare this now. This is the correct flux soldering to K-track. And this is a general flux you can buy in the store wherever. It's also the same type of flux which is already inside the tin, the wire, solder wire. And see, we heat this and then we add our solder wire and nothing happens. It's just a bead of solder there and it's not attached to the tracks. So this does not work. So when you get to the store, make sure to get flux especially for stainless steel. Now there is one special tool we have to make on our own, and it's made from a rail, from some piece of K-track. So I just remove the rail here. It's about a decimeter long. It's not all that tricky. I make a mark 7 millimeters in. Then I take an adjustable spanner and I bend the track there. In addition, we're going to use a side cutter here to also make a stop. And as you already might have guessed, this tool is used to assemble rail joiners. However, just even before we can start laying our tracks, we need some measure of how to transfer your track plan to the plywood. This is also necessary to cut the plywood to shape. And one classic way of doing this is using a yardstick. It has a pivot point with a screw which is pushed into the plywood, and then it has holes for the common curve radiuses you are going to use. And the holes, well, you just stick your pencil through there and you mark and get nice curves on your plywood. If you're using a large portion of sectional tracks or just sectional tracks, then of course it's easiest just to build it on top of the plywood and cut the plywood from that. But working with flex tracks and just turnouts, then an easy way to do this, if you have made your track plan in a program, an application, then you just print it out in full scale. Spread all those papers out, tape them together, and then it's easy for you to make fine adjustments of the exact position of the plywood. With the entire track plan in place, I cut the papers away 50 millimeters, about 2 inches outside the tracks, which represents the edge of the sub road bed, the plywood underneath. So here now I've cut the paper away, the excess paper, which was mostly blank. And with that done, I start to mark the center position of the tracks. And you see here, it leaves just a mark on the plywood. And then you have to fill that mark in with a ballpoint pen. But it looks like this when it's all in place. And for turnouts and for critical positions on the layout, such as where turnout should be placed and straight section starts, etc., I cut out a triangle, and in that triangle I make a special mark so I know that this is a position that I need to maintain and cannot move. With the center position marked for all the tracks, we're ready to lay the track bed. I'm using this product from Woodland Scenics. It's called ST1474. It's a really soft foam type track bed which absorbs the noise beautifully. The downside with it compared to cork is that it's a bit less stable when assembling the tracks. One other advantage, like with the cork, is that it's splittable in the middle, so wherever you have a curve you split it and then you get a flat surface to place your track on. I glue this track bed in place using PVA glue, that's wood glue. Just pour it out like this and then spread it with a piece of wood, and then I put the track bed on top. The advantage with this is that it's kind of easy to remove in case you need. Also, before getting started with the actual laying of tracks, I would like to say a word about second-hand K-tracks, because they have been developed over the time. Here you see an older type with copper contacts for the third rail underneath, or this is actually phosphor bronze or possibly beryllium copper, but it doesn't matter. When copper oxidizes, and it will, because we're pouring glue and all kind of liquids over it to prepare it, it will form an oxide on top, which is electrically non-conductive. The newer tracks, however, they have tinned contacts. And tin has the advantage that when it forms oxide, the oxide is actually a better electrical conductor than pure tin. So with the older type, it's advisable to solder them all together. Same goes with the turnouts. Here they have a hinge pin in the center of the movable part of the turnout. This can create problems with the locomotives, which has a short pickup shoe. On the new turnout up here, you see it's designed in another way. The new turnout also looks prettier. It has less of these glossy surfaces and looks more prototypic. Laying down the first tracks on a new layout is cause for a celebration. So this time I invited a couple of friends. One of them, Jürgen, brought me this. It's a gold-plated rail pin. And we started by pushing this into the first track. And after that, the track laying process can take its start. I always start with a turnout somewhere in the end of the layout, from where I then continue to lay tracks down. And as you see here, we're starting in the Schattenbahnhof, the shadow station. It's a kind of a hidden parking garage for trains. With the first tracks in place, it's important to push all the rails together. Now, since the rails of these flex tracks, they're not fixed to the ties or the sleepers, so they need to be pushed into the track it's connected to. Otherwise, those gaps will remain there forever. We're gonna look now a little closer on working with this flexible track, item number 2205. Comes in packs of 10 like this from Marklin. The thing with this track is that it springs back. So if you bend it, it springs back. Another thing which is unique for these is that the track comes with joiners and that the rail is fixed to the sleepers or the ties in this position. So when creating curves with this track, the rail in the other end will either retract or extend from this point. So in order to take advantage of this design, there is always one direction of laying the tracks which is more favorable than the other. So looking at this curve here as an example, I started to assemble the tracks from the other end up to this curve here, and you'll see if I now push the flexible track into a curve, the other rail will retract and become too short, and then I can anyway not use this rail joiner. So what I will do instead is to assemble the track from the other end. Doing that, then I have the extension on the other side, so the rail without rail joiner extends and simplifies assembly. Another good practice is to solder the joints ahead of and following a curved flex track section. This prevents the rails from forming gaps when you're handling the tracks further down the line. There are fixed positions for the track screws on K-track, and it's also there a hole through the third rail conductor underneath. So it's not possible to apply the track screws anywhere, it has to be in the pre-marked holes. I use a steel scale when cutting the rails. Eventually it will always be necessary to cut the rails as soon as you have created a curve with this flexible track sections. And as mentioned earlier, I use the motor grinder with an extension cord to do the cutting. and then I just put them on top of each other, make a mark using a file, and then I cut the top part as well. I'm working with the hidden levels like this. There will be no ballast or anything. I just simply fix the tracks to the trackbed using the screws. So here I used the special tool we made to slide the rail joiner in place. And with that done, well, it's just to assemble the two track pieces together and then screw it down into the trackbed. And the last action with this curve is to solder the rail ends over the joiner together. Now, along the main lines, it's nice to do some super elevation, meaning banking the curves slightly. Not much, but a bit. It makes a huge difference for the look of the train when passing through the curve. Look here. Here I'm banking whilst the train is turning to the left, and it gives such a nice impression on a main line to do this. And it's really simple, and to avoid overdoing it, I'm using strip styrene here from Evergreen. These are 0.1 millimeter thick. I only have this width of them. I would prefer a bit wider strips, but okay, it works. So I start with one strip, and then like 1.5 decimeter after that one, I increase to 2 strips, and ultimately after another 1.5 decimeter, I increase to 3 strips, and that's as tall as I go. Now, wiring of a layout will be covered in a later video, but anyway, we need to have some track power to test our curve. And the track power is, per Marklin recommendation, is to be connected every 2 meters. Or where the center rail has been cut and we have decided not to assemble one of those snap-on contact pairs. Now, Marklin provides a special track for connecting power to K-track. If you're deciding to use that, make sure to remove the capacitor because it's intended for AC operation only. So if you run digital, remove it. Otherwise, I would say this track is more if you're making a Teppichbahn, meaning a carpet type temporary layout. Instead, I'm soldering wires to the tracks directly. I first grind the center rail conductor underneath, I tin it, and then I also tin the rail on both sides. This is necessary because the rails are isolated, electrically isolated from each other, and you want to have both the rails connected to power. I also advise you to always connect both plus and minus to the track at every power supply point, even though you just cut the center rails for saying it's important to add both to feed symmetric. That's very important for the digital signal. Let's start assembling motors. This is the Marklin provided turnout motor. It snaps into the turnout and is assembled on top like this. I think the appearance is okay for hidden levels like this Schattenbahnhof I'm building, but for turnouts on the surface I prefer using this set from Marklin called 7548. It's a kind of kit which contains parts to assemble 2 turnout motors underneath the sub-road bed. We're gonna have a quick look of how this is assembled and how it turns out. So here's some of the part. What you have here is a drilling template. So I'm detaching it. I'm unsnapping the motor, and in its place I'm snapping in this drill template. Now the instruction says to use a 2.2 millimeter drill. So I'm drilling the 3 holes here with a 2.2 millimeter drill. And then I stick this positioning tool through the holes, and then I can assemble the mounting plate for the turnout motor on the rear. And the reason I'm doing this is to drill the holes for the fixing screws so I get the correct position there. Alright, so now we're gonna make this center hole bigger It should be drilled using a 10mm drill. With the holes in place, we're ready to assemble the motor with the sub-assembly parts. So there's a pin here which will extend up to the turnout on the surface. Then we're inserting that into this plate, the mounting plate below, and it has a cover which is snapped in place there. So now we're ready. All we need to do now is to snap the motor itself into that. So here's the motor also snapped in. So it's a fast and straightforward assembly. Only annoying thing are these screws, which are the old type slotted heads, which is very annoying when lying under the table. So now we got it all in place. This is the cover. You can change this cover. This is a kind of German style looking cover. If you're in another region, there are 3D printable turnout motor tops, which looks better. So this is what it now looks like when it's connected to a M83 decoder. It goes click, click. Now this fast movement is not really what it looks like in real life. So if you want a slower movement, then you should use another motor. Here's an example. This servo is MP1 from a manufacturer called MTB Models, sold by Weinert. Is available on Lippe, for instance, and it has the slower movement. However, this one has a positive common, so it does not work with the Marklin M83 turnout decoder. So if you're choosing this one, you have to choose also other decoders if you're running digitally. And what to expect then? Slower, more realistic movement, and a motor sound when the turnout is operating. So if you think that's important, that's the way to go.
All right, so a big thank you to my friends who helped me out here to lay all the tracks of this first 0 level, the shadow station. Next up is making blocks, because all of this will be automatically controlled. So one train comes in, parks on an empty track, and then you can start another train which comes up on the layout and does its thing. In addition, there's also 2 staging tracks, I would say, which are manually serviced. So there you can change the consist of the freight train for the day. So for instance, once a week I have transports up to the harbor for export goods, etc. So then extra cars are added for that. So have an access area for that. So that's an improvement since I would say my last layout. Thank you very much for watching this video. I hope you have some takeaways and use for the information. If you do, please consider to support the channel by becoming patron. Get over to Patreon, set up a support account there from $1, $2, $4, $20 per month, or make a one-off donation using the PayPal dialog found in the video description below. And if you're not yet a subscriber, subscribe. Enable that little bell and you will get a notification once next video gets published. Until that happens, see ya.